Hey guys, today we're doing chapter 4, section 9, and this section gets a little bit harder, so it's really important that you really understand section 7 and 8 before we move on to this section, because this is combining both of those together. So now we're going to talk about actually doing translations and scale changes at the same time. Okay, so what we want to do is we want to be able to state the amplitude, period, phase shift, and vertical shift for any type of cosine or sine function that they give us. And it's really not that bad for vertical shift and amplitude, because those are pretty obvious whether you look at a graph or whether you look at an actual equation. It's pretty easy to find those things. Now, it's a little harder to find period and phase shift, because what we're doing is we're combining a translation and a scale change at the same time, and that kind of changes the way that it looks in the equation. But what we want to do is basically undo what we've done in the equation in order to find what type of translation and what type of scale change we've actually applied to the problem. So what I've done over here, I put a box that just gives us the steps to find period and phase shift in the easiest way I could think of. So to find period, what you do, you just split up whatever's in your parentheses, take the reciprocal of the x value and multiply that by 2 pi, because whatever you get here, the reciprocal of that x value is considered your a value in your equation. So then you just take a times 2 pi. And then, to find phase shift, all you do is set the value inside the parentheses equal to 0 and solve. Okay, and that'll make a little more sense as we do it. So first thing we have, y equals cosine of 2x plus pi over 3 minus 4. Well, you might look at that and just be like, oh, well, my phase shift is obviously just pi over 3, because if I were to break that up, that'd be like 2/3 x plus pi over 3. Okay, well, it doesn't actually work that way. The reason it doesn't work that way is because what I would have to do if I split this up, this x value here is not just an x value. This is 2/3 x. So technically what I'd have to do is factor out this 2. But I don't want to have to do all that work. So I'm just going to follow the steps up here. I'm going to start with the easy stuff, which is my amplitude and my vertical shift. Just looking at this equation, I can see that if I move this over, I'll have y plus 4. Okay? So I know that what I've done to my function is I have moved it down 4. Okay? So that means my vertical shift is going to be -4. For my amplitude, I have to think about, have I multiplied my y values by anything? Okay, and it looks like I haven't multiplied my y values by anything, because I don't have anything being multiplied by my cosine portion. So my amplitude is just going to remain 1 like it normally was. Okay, now to find my period, I'm going to worry about all the stuff in here. So I'm going to split up whatever's in my parentheses. So I'm going to call this 2x over 3 plus pi over 3. Okay, then I'm going to take the reciprocal of my x value. So my x value, right now it's being multiplied by 2/3. I'm going to take the reciprocal of that, 3/2. And that is what I'm going to multiply by 2 pi. So when I do that, these cancel out and I get 3 pi. So that means my new period is 3 pi. Okay, and then to find my phase shift, I'm going to start by taking whatever's in parentheses, 2x plus pi over 3. I'm going to set that equal to 0, and I'm going to solve it. So if I multiply both sides by 3, I get 2x plus pi equals 0. Then I can subtract pi, I get 2x equals -pi, divide by 2. And that gives me a phase shift of -pi over 2. Okay, so I found the amplitude is 1, the vertical shift is -4, my period is 3 pi, and my phase shift is -pi over 2. Alright guys, just a quick reminder, remember that you always have your formula sheet available to you. And one of the things that's on the formula sheet here at the bottom is the graph standardization theorem and this theorem here. This theorem here is really important, and just so you know, I do have it a little bit wrong on the formula sheet. So it should say y minus k over b equals sine of x minus h over a. So all the stuff in here, this b should be an a, and this b should be an a. So you can go ahead and change that on your formula sheet for the test. Now notice that in this formula, they also give you these. So the amplitude is just the absolute value of b, the period is 2 pi times the absolute value of a, the phase shift is negative h, or I'm sorry, it's h, and the vertical shift is k. So if you can get your equation to look like this, you can pick these out pretty fast. So, knowing that, what I'm going to do is I'm going to rewrite this equation so that it looks like my equation here, and I'm going to pick out my a, b, h, and k values in order to figure out what my translation equation and my scale change equation are. So I'm going to start by subtracting 1, and then I'm going to divide by 3, and that'll give me the sine of 2x minus pi over 2. Now, again, this part in here doesn't quite work out the way that I would hope it would, so I am going to have to do some extra stuff in there to figure those out. But this right away tells me that my k value is 1, okay, and it tells me that my b value is 3. So that helps me, because that tells me my vertical shift and my amplitude. Okay? Now, for this stuff, I'm going to follow those steps again to figure out what my phase shift and my period now are. So I'm going to take 2x minus pi over 2. I'm going to split it up, and then I'm going to take the reciprocal of my x part, so I've got 1/2, and that equals my a value. So then, to get my period, I take 2 pi times a, the absolute value of a, and that gives me pi. So I know that my period is pi. And I know that my a value is 1/2. Okay, then I'm going to take 2x minus pi over 2, set it equal to 0 and solve. So 2x equals pi over 2. If I divide by 2, that gives me x equals pi over 4. So that's going to be my phase shift. So looking at my formula sheet here, it tells me that s of xy equals ax by and t of xy equals x plus h, y plus k. So looking at my formula here, I have my b and k values here, I have my a value here, and this, my phase shift, is just my h value. So if I were to write this scale change and translations equations, I have s of xy equals, my a value is 1/2, so this is x over 2. My b value was 3, so this is 3y. And then for t of xy, my h value was pi over 4. And my k value was 1. So now I've written my scale change and my translation equation, all just using the formulas on my formula sheet. No calculator necessary. Okay, next up, I want to write a function whose graph will have the given characteristics. So they're telling me that my parent function is sine of x, my phase shift is pi over 6, my period is pi, and my amplitude is 1/2. Notice that they don't tell me a vertical shift, so I can just assume that my vertical shift is 0. Okay, aka I don't have one. Alright, so if they tell me that my phase shift is pi over 6, that means my h value is pi over 6. If they tell me my period is pi, well, remember that 2 pi times the absolute value of a gives you your period, so I can write that that equals pi. Then I can divide by 2 pi to find out that a equals 1/2. Okay, my amplitude is 1/2, so that means that my B value equals 1/2. And my vertical shift is 0, so that means that my K value equals 0. So using all that information, I can now write my equation, and I can just use this again. So I can say, if I'm using my parent function of sine of x, I have y minus k, which was 0, over b, which is 1/2, equals the sine of x minus h over a. Okay, now that's pretty ugly. I'm not going to leave it like that. I want to make sure that I simplify it into something that's a lot prettier. Okay, I want y equals something. So here, if I'm dividing by 1/2, I can just multiply both sides by 1/2. So that'll become this right here. So now I've got y equals 1/2 times the sine of. Now remember that if you're dividing by 1/2, that's the same thing as multiplying by 2. So I can rewrite this as 2 times x minus pi over 6. And then I can just distribute that out. So this is going to be 2x minus 2 pi over 6 is pi over 3. So remember back at the beginning when I was talking about factoring stuff out of this? Well, notice that going forward, what I had to do is I had to distribute this stuff. Working backwards, you can see that if I had to factor all that out, it'd be pretty hard to get to that, which is why I give you guys all the formulas and stuff, because I don't want you to have to do all that work. That's a lot of thought to be able to factor that back into this state here. So instead, I just give you the period, the ways to find the period, and the way to find the phase shift, so that you don't have to do all this work. Okay, next one, sketch a graph of the function described. So we've got y equals 2 cosine x plus pi minus 1. Well, if I was going to sketch a graph, the first thing I want to do is just find the amplitude, period, phase shift, and vertical shift. And that's going to help me sketch a graph. So my amplitude, well, that's just going to be this value here. So it's 2. Because remember, amplitude is your B value, and B value is what you divide y by. So this is my amplitude. My vertical shift is -1. Okay, now to find my period and my phase shift. So x plus pi, if I split that up, and then I take the reciprocal of this, that means that my A value is just 1, which means that if I take 2 pi times A, I just get 2 pi. So my period is just 2 pi. Now my phase shift, if I take x plus pi equals 0, I get -pi. So my phase shift is -pi. Now what I'm going to do is I'm going to start by graphing this using my vertical shift and my amplitude, because I like to think about my y values first. So my vertical shift is -1, and I'm just going to count each of these as a half, so this will be my -1. Okay, so this is kind of like my center. Okay, this is kind of like what I like to call my x-axis. Okay, then from there, my amplitude is 2, so that means that I go down 2. So that'll be -3. And I go up 2, so that'll be at 1. Okay. Now my parent function is a cosine graph. So with my cosine graph, normally at 0 I have my maximum point. So normally I would start here. But in this case I have a phase shift of -pi. That means that my new maximum is going to actually be at -pi. Okay? So this is one of the points on my graph. Now from there, I know that I have a period of 2 pi, so it's going to take me 2 pi to get back to where I started. So if I go from -pi up to pi, that's 2 pi. Okay, halfway between that will be my minimum point. So my graph is going to look something like this. And then of course it continues in both directions. Okay? So I know that these types of problems are really tricky. All I can say is that the more you practice, the better off you'll be. Make sure you're using your formula sheet because that's going to help you out a ton. With these types of problems, if you can figure out your A, B, H, and K values, you're set. That's all you need to know to figure out everything else. So think about finding your A, B, H, and K values, which in turn will allow you to come up with scale changes and translations equations. It'll also allow you to come up with amplitude, period, phase shift, and vertical shift, which will in turn allow you to come up with equations or graphs or anything. Okay, so I know it's hard, but we'll get through it. All right, that's everything for section 9.